Bona tarda a tothom. Mireu, això és una xerrada que dins dels grans interrogants de la ciència, que es munta des d'entitats d'aquí d'Olot i on hi col·labora un comitè científic, del qual hi forma part dos exdirectors de l'Institut de la Garrotxa, Antoni Bach i l'Albert Bramont, que van permetre al llarg del temps que es muntés un esdeveniment que es diu Robolot i que arribem a la 24a edició. Per tant, deixa'm dir, atribuir una mica tot això al fil llarg dels 24 anys que ha funcionat a Robolot, que va sortir de l'Institut de la Garrotxa i ara s'ha fet com molt universal. I res, i com que tendeixo a enrotllar-me molt, doncs faré una presentació ben curta. La tecnologia és només una eina. Es pot utilitzar per coses interessantíssimes i per coses que no són gaire desitjables. Jens Mönig és un col·laborador de Robolot des de ja fa molt de temps, fa 8 anys que ve cap aquí. Treballa, o sigui, es dedica a fer software didàctic conjuntament amb tot un equip de gent de Berkeley, que el tenim a Faber ara mateix, i diguéssim que tant ell com 3 o 4 persones més treballen habitualment a Heidelberg. Tenim un català també que treballen amb ells, que es diu Bernat Romagosa, i treballa per una... O sigui, diguéssim, ell és un pedagog. Per aquí posa advocat. Sí, ell era advocat, però és un dels millors pedagogs i informàtics de la part didàctica que existeixen. I d'una empresa que es diu SAP, que és l'empresa de serveis més gran que hi ha al món. Té 150.000 treballadors, amb seu a Alemanya, i és tot un honor tenir-la aquí. Dir-vos simplement una cosa, i és que pots ser consumidor de tecnologia i prendre mal, o simplement distreure't en la tecnologia, o pots ser creador de tecnologia. En Jens és creador de tecnologia i no ens explicarà com funciona, com utilitzar la intel·ligència artificial, sinó una mica d'on ve tot això perquè entenguem una mica internament com funciona. Moltes gràcies, Jens, i endavant.
Thank you, Tony. Thank you, everybody. Hi. Wow, it's raining and everybody is in here. Thanks for the rain. Otherwise, you'd all have stayed outside. My name is Jens Mönig. I'm from Germany. It said on the slide that I'm a lawyer. Thank you for coming anyway. Everybody loves lawyers. I work at SAP, a software company. I think it's Europe's biggest software company. I used to be a lawyer, but I'm a programmer for many years now. SAP is working on enterprise software to take care of the needs of corporations. The group that I'm working in is also working on software, but not for enterprises, not software that is sold, but open software, free software, a programming language for children and for students, and that is called Snap. Before that, I used to work for the programming language Scratch. And today, I'd like to explain something to you that I've just learned myself, that we just learned ourselves last year, how to explain to your children or to your neighbors or to your friends how the basics of a generative artificial intelligence system works, how it makes up things like a chatbot or stories. And in order to do this, I will try to program this live on stage. I'm really, really very excited when I do this. So if I get it wrong, I'm trusting that you will correct me and we will find the errors together. So I'm here for like the past years for the gathering like Steam Makers and Robolot, when teachers come here to program together and to learn together. And this is the reason why I'm here at the Institut Ramon Llull and the Faber residency. And this is what we're trying to do, though, has nothing to do with robots, not with physical robots, but with virtual robots, something that doesn't, construct things, but something that constructs sentences, words, conversations. So I'm calling this chat a lot and like to get a little bit into this. Of course, when I'm here in Olot, when I'm here in Catalonia, I always get reminded that artificial intelligence, and especially generative artificial intelligence, started right here. And Catalonia is where it all started back in the year 1308, as Ramon Llull finished his big book, his Ars Magna. And of course, you all know Ramon Llull, the creator, kind of the first big soul of the Catalan language, because he was writing his things, some in Latin, some in Catalan. The Ars Magna was written in Latin. And in the Ars Magna, really, Llull went through a machine of language that would combine, would go through the permutations of symbols, of letters. And Ramon Llull knew that if you start with a certain set of facts and combine it, go through a permutation of a certain other set of facts, out of these combinations you could generate deduced facts and thus generate knowledge out from something you knew. And this is really interesting because, as far as I think everybody agrees, this kind of was the first way to do this. And he was very influenced by Islamic geometry, Islamic mathematics, which often went in spiral patterns, geometric patterns. And Ramon Llull took these and simplified these into dials, into round shapes. And he also went and visualized these combinations. And if you look at these combinations here, it really is like a web, like a network, right, where there are combinations. And if you look at this, this is like really centuries old. It only took a couple of centuries for this idea really to catch on, because this is pretty much exactly the combinations from facts, from inputs to outputs, how the technology behind neural networks and much of artificial intelligence works today. So the idea that you deduce truths and facts from given facts by forming combinations. And what I'd like to show you today is how to go and very kind of simplify down to points where we can actually understand the algorithm or parts of the algorithm behind generative AI. And there are really three things I'd like you to remember when you walk out of here, because I can go on and talk for an hour and you'll say, yeah, Jens, he waved with his hands and he was German and he was a lawyer. But there are three things that I'd like you to remember. That is that artificial intelligence, generative artificial intelligence, uses something that is called a statistical model. And that's a big word. That's like everybody's nodding with their head and said, oh, I was missing in class when we did this in math class. So a statistical model really is nothing but a sack full of links, of connections. It's a bunch of connections. And if you follow links, same as if you follow connections and links on a web page. From one link to another, you generate a chain of content. And those are the three ideas. Okay, now I'm done. You can go anytime when you want. Everything I'm now going to show you is just going to reiterate on this. So let's start with a chatbot. This all, when we were thinking about how to explain this, I don't know, anybody know the Brothers Grimm fairy tales? They're German. The Americans stole them for Disney, so other countries now know them too. And so we thought, when we explain this, we start with fairy tales. Wouldn't it be nice to train an artificial intelligence with fairy tales so it could, generate fairy tales? So when my kids go to sleep at night, I can say, okay, please tell them a fairy tale. I'm going to sleep myself. This is what we're doing. So we all know how fairy tales start. The first words. In German, it's es war einmal. In English, once upon a time, right? And then the question is, but how does it go on? Like, we all know, once upon a time, and then, oh, now I need to invent something. And I'd like to show you now how we find the next token, the next words to form a picture. So this is the first idea. And the other idea is, how do we talk about these links? When I said a statistical model is a collection of links. And one thing that's actually my son told me, this is like, anybody know this? Anybody know domino? So I bought these huge domino things because so old people like I can see them. And so when I explain this to kids, I always say, like, I don't know how to play domino. Can anybody explain to me how to play? And always people will tell me, you have to find numbers that match. Like I can put the 5 to the 5. Now I have a connection. The 4 to the 5 to the 5 to the 6. Okay, then I need to find another one. And here's no, that doesn't work, but this does work. And now, and by placing things that match alongside each other, we can find longer chains, longer connections. We can stitch them together. So the interesting thing is, if you look at one of these domino bricks, it has 2 numbers, kind of 2 die numbers on them. And that's important. If there were just 1 number on there, it wouldn't help us. But since each brick has 2 numbers, we can place them alongside each other's, and we can find a connection from one number to a seemingly unrelated number through a common link. And that's the idea behind a statistical model. And I was told that this is how some people in France apparently play domino. Like in Germany, we put them all together in one row. I like this because it looks a little bit more complicated. So I'm going to try to program a chatbot now. Can we all see this? Is this too little? Let me see. It's kind of okay. So what I did is, I looked for these fairy tales. A good thing about fairy tales, because I'm a lawyer, usually when you train an artificial intelligence with some knowledge, there's copyright issues or there's personal data. With fairy tales, you don't have the problem. The Brothers Grimm are long since dead. There is no personal identifiable data, and there Hansel and Gretel and the witch don't really exist, so we can use this for our artificial intelligence. So what I did is I searched for 30 fairy tales. And these are just 30 fairy tales, 7 Swabians. I'm from Swabia, from Stuttgart, so I start with that fairy tale. And I just looked for 30 fairy tales and put them all one after another. Right? So it's just a pile of fairy tales. And I'd like to train an artificial intelligence with this. So here is the programming language I'm going to use. It's Snap, and I want to try to do this with a little project. Here are a couple of blocks I need, and I'm going to import these 30 fairy tales into the programming language. Now I've got it imported, and I have this is called a variable in here. So you can see here's my 30 fairy tales. If I click on these 30 fairy tales, I see, yes, it's a text. Now this text is not very useful because now I need to turn this text into domino bricks. That's the idea. So in order to turn the text into domino bricks, I can split it. So if I split the words hello world by letters, I'm getting a list of the letters world, right? I can also split it by I can split it by words. Now I'm getting hello world. If I take my 30 fairy tales and split them by word, I'm getting a very long list of 57,362 words. Now, this is not the vocabulary of the Brothers Grimm. Nobody has a vocabulary of 52,000 words. It's just the fairy tales written, every word written underneath each other instead of besides each other. And words will be there more than one time. It's really just the same fairy tales, but a very long list. Now, of course, a very long list would be the same thing as having a brick with just one number. What I need is I need to put them into pairs of words so I can play domino with these words. And while I'm at it, it would be nice to maybe generalize this idea to not just turn them into pairs, but also into triples or quadruples or chains of 5. And this is what they call n-grams. N is the number that tells me how long the chain of words should be. And you call, like, if it's just one word, you call it monogram. If it's 2 words, it's a bigram. 3 words are called trigrams. So I want to make a function that does that for me. It's like a machine that cuts up things. So I'm going to make a new category of blocks that I'm calling generative AI. And in it, I'm going to make a function, a new block, that is generative AI, a block that should return something which is the n-grams of something that is called a corpus. A corpus is all the fairy tales, a list of words. When I do this, I get a new block, a function. I can specify the inputs. N is going to be the input, it's going to be the number that denotes the length. And a corpus is also an input, and it should be the list. So now I have something as a block, and I would, for example, like to get all the pairs, all the domino bricks of the fairy tales. If I click this now, nothing happens because I haven't programmed anything. So what I'm now going to show you is how we program this block. If you don't understand that, no problem. It'll be done very quickly, I hope, unless I make a mistake. And this is kind of the most complicated thing I'm going to show you, and I promise I'm not going to do much more complicated things. So what we do in order to turn this into chains is we try to get the indices of every word. So we get the numbers from 1 to the length of the corpus, but we want to only go as far because we're doing this with 2 words or 3 words. So we want to go only to the end offset by the n. So now we've got all the numbers, and what we do here is we want to map over them. We want to apply a function in here for this. So when I have a list, for example, a list of the words, 1, whoops, I should be able to type, 2, 3, 4. this is a list, I can use the item block to get the first item. I can get, the third item with this. If I use a list of numbers in here, like the list of numbers 2 and 3, what I get is a list of consecutive words. So I can get with this more than one word. And this is exactly what I want to do. Instead of the list 1, 2, 3, I now want to get the items of the corpus, and I want to get the numbers from whichever is the number to the number plus n minus 1. So I'm sorry if this is complicated. What I'd like to show you is that it's just a few blocks. Even though you might be confused by what it actually does, it's not really complicated. It's not really rocket science. It's not really hard mathematics. Now, I hope it works. Let me try this. So if I now get the bigrams of the 30 fairy tales, you see what I'm getting? 7 Swabians. Swabians were once. I'm getting exactly these domino bricks. So it's not, they're always a little bit overlapping. So I can put them together like domino bricks, and I would again get the original corpus of fairy tales. Now, a cool thing is, I can also enter another number here. I can, for example, say, what if I do the trigrams of this? If I do the trigrams, what I'm getting is 7 Swabians were. Swabians were once. And that's interesting. So I can now take this corpus and cut it up into subchains of different lengths. So I could, for example, now that I have this function, I could apply it and say, I'm going to map this function over the numbers from 1 to 5. So if I do this now, and if I evaluate this, I'm getting a very strange table, but it only looks strange at first. When I view it as a list, what I'm getting is a list of 5 entries. The first item of the list is the monograms, just one word. The second item of the list is the pairs. The third item, right? You get the idea, right? And then there's 4, and then there's 5. This is like a staircase, like a cascade of cutting up the fairy tales into subchains of different lengths. And this literally is a statistical model, because I now have a sack full of links, of connections. So what I can do is, I can make a new variable. I'm going to call it model, and I'm going to assign the model to the result of calling this function. So I'm going to do this now. Now I can test my model. I can test it. I can say, give me the first item of the model. And the first item of the model is, the monograms. The second item is the pairs. So you see, whatever number I put in here is the length that I'm getting. So here, like the 4-word lists, 7 Swabians were once, Swabians were once together. This is now my model, a statistical model. It is way bigger than the original set of fairy tales that I loaded, because it is sort of exploded. So now, if I have a list of words, and let's say that list goes once upon a. How could I find the next token? How could I find a way how this list, how could I find a next word, a plausible next word in that sentence? I'm not going to ask you because I might not understand your language, unless anybody has an English idea. Okay, I'm just going to show you. So the idea is, now that we have a model, we could look in the table with 4 columns. I could look for those records where in the first column there is the word once, in the second column there is the word upon, and in the third column there is the word And then whatever is in the fourth column would be an option of something that has happened before, and that seems plausible, right? So it's basically a lookup table. It's basically a database. We can search in the database for records, just like any database. So I'm going to do this. So I'm going to search in the database, which means I'm going to keep the items. I'm going to keep those. I'm going to filter those that equal the list once upon a time. And I want to get only the first 3 items. So I'm getting the numbers 1 to 3 in that database. So this is my database query. Again, it's not fancy. It's not difficult. Let's try whether it works. So it suggests that time might be a good next word for once upon a. And so you can see it found 9 occurrences. So we can test this with other words. Let's say the old woman. What would be a good way for the old woman? Let's find all this. The old woman urged. The old woman took. The old woman took, quickly, had, spoke. So there's many ways. You can already see that some of the records that it found are doubles, duplicates. Like there are 2 duplicates, like took. Another took. So I did not normalize this model. I didn't make every entry unique and count them, but instead they're in here with the same number of occurrences that they're in the original fairy tale. And this is not how it is in real life. ChatGPT works differently, but for teaching it, for explaining it, it's actually very great. Because now, if I pick any random record here, the probability is exactly the same as it is in the corpus of fairy tales that I trained my artificial intelligence with. So now, what I can, let's try something else, like the king's son, another. Like now I can, for example, take any random element. If I take a random element here, I'm getting a single record. And here I can actually get the last one, the last item here. And now the king's son, if I click on this, followed. The king's son said. The king's son, like there's some randomness involved. It's a stochastic model. And this is really the other building block of generative AI. It's finding the next token in something. And so I've made this block, and we usually give this to kids. This is the, let me find it, where is it? The next item block. This does just that. It's the next item in a model, the next item in a story, like the king's son, based on a model, does just that. So now we have 2 blocks. One that cuts up a corpus of knowledge into a statistical model, and another block that finds the next item in a list, the next token. And this is really the fundamentals of generative AI. This is all you need to now build your own chatbot or your own fairy tale generator. And let me actually just do this. Now we can program this like children would. For example, I could say, when the green flag is clicked, I want to ask something. I want to ask the user, not what's your name, but start a new fairy tale. and wait. So if I click this, I can now say, once upon a, right? So this is the beginning of the fairy tale. I say yes. And now what I typed in is here in this answer variable. So what I need is, now I want to make a story. I want my robot, my chatbot, to make a story. And I would say, okay, I'm going to initialize the story to not this answer, but I need a list. So I will split the answer by the word. If I do this, now my story is a list of words. And now I can get the next item in the story based on the model. This is the other block, right? So if I click on here, oh, once upon a time, great. So now I have the next token in the fairy tale. What do I do with it? Now I've found the next word. What do I do with it? So the idea really is almost provocative. Now I've found the next word. I add it to the story, right? So what I could do is, now I'm adding the next item in the story based on the model to the story. And that's interesting. That's sort of like a self-hosting system, like something that like the snake biting its own tail. So I modify the story by just adding things and then looking for the next word of that, right? So I could do this, and while I'm doing this, it would be nice to show the story. So I could say, okay, I want to say the story, but the story is just a list, and I would like to turn it into text again. So I can say, I want the text of a story, and I'm going to say this on the stage. And this should happen, for example, whenever I press the space button. So let's actually try this. So let's say, okay, once upon a, now I'm pressing it, once upon a time. And now see what happens when I keep pressing the space button. So I keep pressing the space button, and it now stitches together kind of plausible sentences, and even with interpunctuation, with commas, and it makes up sentences that are plausible by playing domino with itself. Now, if you look at this, if you know the fairy tales of the Brothers Grimm, you will notice that it sometimes takes these fairy tales verbatim, like one word by word, and then suddenly it will switch to another fairy tale, so the story doesn't make much sense. But each sentence makes sense. So really what we're getting is, we're getting plausible sentences, but not so great stories. But all in all, it's kind of amazing because it doesn't know anything about grammar. It doesn't know anything about subject, predicate, object. It doesn't know anything about verbs. So often when we explain artificial intelligence, what people think it does is that we feed it all the internet, and then it learns the rules of our language. But it doesn't do that. All it does is it chops up sentences and chains them together by whether they have occurred in that order before, in that context. So this is fun, but it's also, let's actually take maybe something Spanish. So a friend of mine, Jesus Moreno Leon, took the 40 Fabulas of Aesop, the Spanish version. So if we take these, and we train our model, instead of the 30 fairy tales, with the 40 Fabulas, and I'm only going to split them to 1, 2, 3 because they're not so much. If we do this, now my model is Spanish. I'm going to try this again. I don't know any Spanish. I'm just going to say okay, so it's going to start with a random word. And now I'm just going to, okay. So now it is doing something in Spanish. I have no idea whether it works. You all know Spanish, I guess. So the thing is, it doesn't know anything about language. It cannot translate these things, but it knows things that have occurred like this before, and it can do this in any language. And so basically, it's not as smart as we think it is. Is this the truth? No, it's just like it is talking as if it knew something about. If you feed it the news of the last 2 weeks, it will produce something that sounds like the news of tomorrow. If you feed it the weather forecasts of the last 2 weeks, it will make a weather forecast for tomorrow. Is this how the weather is going to be? Maybe in a lot, because in a lot every day, every weather happens. But is it true? Probably not. And this is another great way why we use fairy tales for this. It is making as if it knew something about it. It is making plausible assumptions. It is sounding as if it were an expert on fables or fairy tales. What I like about this is, look, we can do this with just 3 scripts. This is really all it takes. Is this how ChatGPT works? No. This is the central part of how it works. This is the so-called next token prediction system. There are more bells and whistles to the big generative AI programs, but it boils down to this. Everything else is sort of tacked onto this to make it more plausible, to make it remember what we're talking about across several pages, and to have lists of synonyms, so we're not always talking about the same words. And if you think about this, I'd like to show you something more, because here are these blocks, and I only need 2 blocks. The n-grams of a corpus and the next item in a list based on a model. And this is a little bit of stuffy word. Why doesn't Jens say the next word in the fairy tale, or the next word in the story, or what's the next word? Why is it like the next item in a sequence based on a model? That's very kind of sciencey, kind of, you know. And the reason is because we can try this on other kinds of media as well. So I've now kind of shown you to find the next word in something, because we were able to chop it up into pairs of words. What if we take something else that is not language, but that is also a sequence? So here's something that I like myself. I love music. Anybody else likes music? Okay, I'm not a great musician, but I like music. I appreciate it very much. So what I've done is I've taken 20 songs. I have 20 German songs and 20 American songs. Which ones should I take? The American ones. Maybe you know them better. 20 American songs that I could remember, and I've transcribed them. Now, a song is not a collection of words, but it's a sequence of notes, of musical notes. Anybody play a musical instrument? Yes. So a note has 2 features. It's the pitch, and the pitch is usually, when we're in computers, it's a number. It's basically, if you think about a piano, is the numbers of the keys. Like the number of the keys 1 to 88. That's the pitch, how high the note is. And the second feature is how many beats do you hold it. And if you have these 2 things, you can play a melody. And so this is a melody. So I can play this. Let me actually play this. I can say for each. I'm going to call this not item, but next note in these 20 songs. I want to play this. And what I want to play is each note. Now, a note here has these 2 inputs. So I'm going to take the first item of the note. This is the pitch. And the second item of the note is the duration. Okay, let's try this. Does it work? Maybe I should have tried this before. Okay. So these are really the 20 songs. I now leave you until this is finished. Okay, no. Okay, then there's the next song, and so there's 20 of them. I made them all in C major, so, okay, you get it. Oh, wait, stop. Okay. What if I did the exact same thing that I did with fairy tales with songs? So instead of setting my model to the words, I would take this out and just take the engrams of the 20 songs. It's the exact same thing. It uses the exact same building block. Now, if I do this, I have not a language model, but a small music model. Okay, let's try to do the exact same thing that I did with the fairy tales with this. So I will make a new song, and I will initialize the song to be a list. Then I need to find the next note. So I'm setting the next note to, now I need my second block. The next note is the next item in the song based on what is now a music model. So what I want to do with this, I want to play it, so I already know how to do this. And then I again want to add it to the song, right? So I want to add the next note to the song. And I want to do this over and over. Okay. So this is now my script. I'm really, really excited when I do this. I hope it works. Let's try this. And now it improvises music in the style of American children's songs. It doesn't know anything about music theory. It doesn't know anything about harmony, about metrics, about rhythm. And yet, it sings these songs the same way like I sing them under the shower. Like I'm oscillating, like, oh, here's something that sounds familiar. Oh, maybe I'm singing this other song. And it can go on forever and compose music. And these aren't even songs that exist. Like it comes up with new ones because it knows plausible ways to complete music. And this part is interesting because what we're seeing here is, what I'd like to show you is that, the same blocks, the same two blocks, the method of cutting up a corpus that is sequential media into building blocks that link to each other, allow us to remix them in different ways. And if we can do it, an artificial intelligence can do it. And so really, the knowledge that's in there is human-made because we've put them into a sequence, and that is basically our cultural contribution. And with that cultural contribution, an artificial intelligence can create other combinations, like Ramon Llull did other combinations out of and permutations of things that already existed, thus producing more knowledge and new things. And this is also why the same companies that make chatbots, Gemini or ChatGPT, keep producing software that produces other kinds of media, that make movies, that make pictures. So this is really what they're talking about when the Americans talk about general artificial intelligence, artificial general intelligence, AGI. it's not that they found the philosopher's stone to what is the nature of intelligence. All they're saying is we have a bunch of programs that we can use for different things, like for anything that is sequential. So we can make our own texts, we can make our own music. What we try to do is, what about using the same thing to make pictures, to make graphics? You're saying, like, it doesn't work, right? Because it's not a sequence. It's a plane. It has more than one dimension. And you're right, so I can't show you this, sorry. But then we came up and said, you know, maybe not a picture, but if I write something, if I just take a pen, if I just take a pencil and draw something on a sheet of paper, it is really a sequence of decisions where to turn the pen, like where to go next, which direction to go. If it's a sequence, we should be able to try this. Let's actually try this. And like, you know, like any TV cook, I've prepared this so you don't have to endure me kind of trying to live code this again. So I've prepared these two scripts, and you'll see that they're the exact same thing. Here's a script that lets me draw something, and what it does is it remembers each next direction as a line, and then it makes a model of this. So let me just try to do this. I'm going to write something like okay. Wow. So this is Jens kind of trying to write as we. Do you write the same way? This is how we teach it to kids in Germany. So now I have written something, and this uses the one block. This is the Grans block. Now let's do the counterpart. The counterpart is, okay, let's try to find, look at this. Let's try to find the next item in something. So if I run this, it imitates my handwriting. Like it's the same bad handwriting as I. Of course, it doesn't make sense, like doesn't know what it is writing. And there's something new like every time I try this. But it's clearly my handwriting. I guess any scriptologist would see, yes, this is Jens. And it's fun because now this is not data that I've downloaded from the internet or something that I've transcribed. This is something I can enter live, and I get a live response. So we've played, when we found this out, we've played with this for days. This is a great thing. Nobody knew that we were doing this. Everybody thought we were doing serious work. And then our friend Bernat from Catalonia said, you know, it doesn't work so well with handwriting because, yeah, it just looks like handwriting. But what if, you know, we draw something that looks like a city, like something like where there's a tower, and maybe there's something like a castle. So here's a castle. And yeah, well, how about a house? So here's a house. And then our other colleague, Yatka, said, and a moat. Okay, so a castle. So let's try to build it on this. Let's start what happens when I do this, okay? Oh, it's a skyline. Oh, and off it goes. Let's try it again. It's a horizon. It's a city. It's a medieval castle. Look at this, wow. So now this artificial intelligence is going to produce landscapes and horizons in the style that I made. And we thought this is really amazing. So we have the exact same two blocks for really any kind of medium. Now, is this really an horizon? Is this a castle? No, it's not. It's just a line. It's just, putting stuff together. It doesn't mean anything. It means something because I want it to mean something. Because when I drew the first thing, I said, oh, this is a tower, and this is a castle, and this is a house. So now I'm seeing what I want to see. I'm seeing a castle. So is it intelligent? No, the intelligence happens literally when I look at it, because I am associating something with it. And this is really the secret of, I think, us humans. We are starving for meaning, starving for communication. Our brains are screaming for input. And whenever we get something, we fill up the spaces in between with these little words, because, despite, and so we make meaning out of lines. And this is really something we should remember, that when we see something, it is because we see it, and it is not this. So, as we should not confuse causation for correlation, we also should not confuse correlation for creativity. Thank you. Do I have to turn this on? No. Okay.
Gràcies, Jens. Thank you. No sé si algú vol fer alguna pregunta.
Shown you everything. I don't know anything anyway, so.
A question generator. A question generator me to do.
Oh yeah, right. I could train it with your question.
Us ha deixat aturats a tots.
Gràcies, Jens, per la teva presentació i la teva xerrada. Igual que ens has donat exemples dels contes dels germans Grimm, d'altres contes de la llista de cançons, tens algun exemple d'una llista de dibuixos teus o d'algú que hagis processat i que hagis fet un generador de dibuixos semblant a algú? Si ho tens aquí per casualitat, o potser no, o potser ho has provat i has arribat a resultats interessants. Si ens pots explicar alguna cosa d'això? Gràcies.
Great question, Enrique. Thank you. See, somebody has a question. So I'm sorry I don't have many pictures to show you because they all didn't turn out so well. It's basically Bernard's idea about the horizon that works well because we can see something with it. What I, as a former lawyer, of course, tried was to make laws. So what I did is I took the German Grundgesetz, our constitution, and I trained it on our constitution. And the result was very, very disappointing and very discouraging. Like, the Constitution is a great document with, human rights and citizen rights. And what came out seemed like a very mundane, piece of regulations that sound like it's the, whatever it is to like parking regulation or whatever. So it was very, wasn't very great. But that might also tell us something because it reflects basically that, some combinations are better than others. And mind you, this is only part of how generative AI works. This is only the next token prediction part. Now, contemporary modern systems have more components that make sure that what comes out makes more sense. This part that I've shown you right now was, as far as I can see, first described in 1948 by Claude Shannon in his article about a mathematical theory of communication. He's the first one who described this. This is also called, for the mathematicians among you, a Markov chain. This is the Markov chain part. Anybody know Markov? Okay, Andrei Andreevich Markov, a Russian mathematician, 1905, he thought about what would happen if you're completely drunk and like you don't know where you're walking. And what if you're right next to a cliff and you're completely drunk? Like, what are the odds that you're falling to death? And he posted this on his chat group of extreme mathematicians, and others found it so exciting, so they thought, oh, what if you don't die at your first step? What are the odds of dying at the second step? Like when you're here, now it might take 2 steps until there's, and by thinking about these things in 1905, they eventually came up with this idea that you can make up chains of things by having a very short memory, because you don't remember where you've been. Each step is something that doesn't require thinking about all the steps that you've taken until then. And for computing, this is an interesting concept, because if you needed to remember everything that you did before, think about not just writing a page of text, but a whole book. It would take longer for every word, because for every next word, you'd again have to check everything before. It would take an exponential amount of processing power and memory. And by thinking about drunken Russian mathematicians, these systems can now make up drunken content. Good idea, I should try. Maybe I should even cook them then. Yeah.
Bé, estic impressionat, el que has explicat. La pregunta és, has posat l'exemple de la Constitució alemanya i va sortir un xurro, vale? Però si jo de forma vaig traient xurros diferents i dic, mira, aquest m'agrada més que l'altre i té més sentit, aquest model finalment faria una Constitució de veritat?
Probably not with this model. So please keep in mind that what I've shown you is an explanation that we made for didactic, for pedagogical reasons. So this is how we explain to kids, but also to teachers, how a next token prediction system works. I wanted you to take away 3 things. It's about a statistical model. A statistical model is a bunch of links. If you follow links, you generate content. That's it. For when we think about how to explain things to children, to students, but also to teachers, we think about the easiest way, the simplest way we can do something, so there's some aha moment. Oh, I thought there was way more behind this. So we try to come up with something that just barely works, but the part that does work already sort of amazes you because you didn't expect it. And this is what often happens even with educators, even with mathematicians whom we're showing this, because they expected it to learn structure, to learn rules. And here's really a realization that most of these artificial intelligence systems really do not learn rules. They only learn correlations, things that happened before. So modern systems that do not just stitch together domino bricks have more bells and whistles, have reasoning parts, have parts where they can keep context, where they don't switch like from one sentence to the next sentence, they don't switch the corpus. So you might be able to get things out of there, but that might be better, you know, that's a judgment that you make. But there's one thing to remember. when we're talking about better, always think of the artifact of an artificial intelligence not as a set of truth, but as something that is said as if it knew something about it. Always as if it were in a grammatical subjunctive, an irrealis, something as if it were true. It is only sounding as if it knew something about it. It is not the truth. That's the kind of the core part I try to bring it across.
Bé, moltes gràcies perquè ha sigut espectacular. Perquè sempre sembla una black box, una caixa negra el que hi ha darrere de la intel·ligència artificial i és difícil d'entendre i tu ho has explicat perfectament. I ara em pregunto, que ho has dit ara una miqueta, però com de lluny està la nostra manera com pensa el cervell? Si bé tu dius que és diferent, jo no sé si el cervell, com de lluny està, com funciona el nostre cervell, com has explicat tu, perquè en realitat el nostre cervell també funciona per una certa estadística o les relacions d'idees que tenim funcionen molt similar a això o no? Com creus de lluny que està el funcionament del nostre cervell respecte al model que tu ens has explicat?
Great question. I have that question too. I don't know. Something that makes me think twice is that there is a lot of vocabulary involved with, like the word intelligence. That is something that we associate with being human. So when we talk about intelligence, we're immediately making a link to ourselves and we're comparing it to ourselves. There is something about language that is very human because we crave for interaction, for communication. So we immediately identify, we give it a personality. There's something about music that touches us emotionally, we can't help it. Like when we listen to music, it has sort of a direct access to not our brains, but to our hearts. And so these things often mislead us. And when we give them names like these networks, these algorithms, we call them neural networks by kind of likening them to the cells in our brains. I'm not a brain doctor, but I would be very, very skeptical whether our brain works the way like a neural network works. Maybe not. If I think about, how much energy it takes to do something like a large language model, like they're talking about building nuclear power plants to train these damn things. When I look at the birds out, like even a small bird is obviously intelligent. I saw one in a cafe at the Café Fiat today, inside picking crumbs. Like, how did it get in? How does it get out again? Clearly, it is intelligent. Does it need a nuclear power plant to power its brain? No. So there must be something way different that we haven't yet understood. And probably the model of artificial intelligence that we're following now is spectacularly wrong, but it leads to nice results, to results that touch us like art touches us. Is art how we work? Maybe, maybe not. So I think what we're seeing here is something that imitates us because we want it to imitate us. There are other ways that imitate us. Art, statues. Are statues artificial humans? Probably not. They look like humans. They don't move like humans. So I think there might be parallels. I would be amazed if things that look and feel the same don't share a set of same features or a set of same rules, but still the overlap might be very, very small. Sorry, I can't answer your question any better.
Nosaltres també copiem. Quan creem música o creem art, també estem copiant altres persones. Per tant, estem agafant patrons, o sigui, a la llista que tu has ensenyat, nosaltres el nostre cervell està agafant patrons. Si ens toca, how you said, when it touches a music, és perquè aquell patró el tenim a dintre, però també està copiat d'una altra persona. Per tant, és que és molt similar.
Absolutely. Most of what we do, we process because we've seen it before, we've been impressed by it, we've been inspired by it. If you think about educating, if you think about raising a child, we lead by example. An example is exactly that. Please follow my example. I've shown you, so you do the same. Like when we think about pedagogy in school, we think about what are good examples. So I show you 3 examples, so now you can transfer it to something you haven't seen before, which is sort of an act of abstraction. Yes, certainly, this is something, and I think it's very, very valuable. Personally, I think copying is exactly what is expected. And sometimes you copying it and making errors in copying is exactly the right thing, because otherwise there would be no development. Like we would still be what we would like. Some of it might be curiosity, some of it might just be a misunderstanding. And misunderstandings sometimes lead to new ideas. Yes, I would agree.
Molt interessant i molt pedagògica la presentació, gràcies. Hem vist que com és d'important el tamany del corpus, com deies, per poder generar coses amb sentit, no? Hem vist que a partir de les 30 fàbules de Grimm es generava un text amb més sentit que quan parties de les fàbules d'Aesop, perquè el tamany era més petit. I podria ser que amb la intel·ligència artificial s'estigui ampliant i perpetuant tot allò que és majoritari, que hi ha més representació a internet, i que en canvi tot allò que és més minoritari es vagi quedant com enquistat i perdi representació. Vull dir, a mesura que la intel·ligència artificial va guanyant presència a la nostra vida, no? Cada cop més.
Great point. I have to first contradict you. The corpus wasn't big. It was 30 fairy tales. The fairy tales are very small. So it was just barely working to get some sentences out of it. And the Aesop's fables were even less so. So I had to reduce what we call the context window, because otherwise it would have copied them word by word. First answer is, there is something interesting, because in seeing that the Aesop's fables were very close to the original, it is usually possible to get the corpus out of an artificial intelligence by what we call prompt engineering. And that is precisely the case of the lawsuit that the New York Times has brought up against ChatGPT, because it was trained on copyrighted data by the New York Times. So that's the first thing. The other question is about bias, about how well balanced is it? And yes, doesn't it make us afraid, because what's on the internet is not everything. There's a lot on the internet, but there's a lot that was invented before the internet that has never been scanned. And also there are many things that are just plain wrong. And many things that we don't want to remix. Like, it's nice to think about fairy tales, but let me tell you one thing. I've shown this very fairy tale thing to my friends at University of Berkeley. And just as we were meeting now in a lot yesterday, my friend Dan Garcia from UC Berkeley said, Jens, I've used this example, and suddenly it said, the Jew cannot be trusted. The Jew wants your money. And I was like, ah. And we looked at the corpus and we found, yeah, there's a fairy tale that has a Jew in there, and it's very biased against Jews. So before I came here, I looked through all the corpus and exchanged this fairy tale. I didn't even know it was in there. I just took 30. So yes, there is bias in there, and there is overrepresentation in there, and there might be things in there that we don't want in there, racist things. And we sometimes do this with children. Like, imagine Hansel and Gretel. There's a witch in there. Yeah, that's nice, but, isn't a witch maybe something that discriminates against old women, that they eat small kids? Maybe it's not really great to, it's fun, but think about it. So we can think about how do you train these models to be less biased against people? And it's actually a nice way, so we can think about how would we do this? Like, we could say there's a list of words. When the next word is one of, witch or Jew, we don't want that word. We say, keep looking for another one, right? And this is actually something that we need to be doing to these corpuses. And it's a very interesting field of study, how to make the answers equitable. And one way, for example, is, that's very interesting, finding out a model that discriminates against minorities. And then finding out why it does that and changing, for example, the weights in a neural network. But that's kind of like you said, it's kind of like doing an open brain surgery on a neural net. Is it great? I don't know. It's a mirror of society. And yes, I agree that it's a problem. And there's an even, the last thing I'm going to say, there's an even greater problem. Think about all the internet and all the chatbots that are out there. So they're now constantly creating these things in which they remix something. And those artifacts, those fairy tales, that music, those pictures, they again go out to the internet and they pollute the corpus. Now, my son loves drawing, he's an illustrator, and he tells me that it's almost impossible to Google for the works of artists anymore because the first examples you're going to get is all just AI stuff. It's very hard to find an original artwork from an actual artist, from an actual illustrator anymore. And of course, with more iterations, the quality degrades. We get more and more of things that are not really original, and so the quality of the language disappears, the quality of our artifacts disappear, and this might have consequences if we learn from these things. I think this is one thing that I worry about a lot. Yes.
Hola, muchas gracias por que ens expliques. Una pregunta que se m'acudeix és, lo desitjable és que la intel·ligència artificial arribi a ser creativa, perquè la creativitat jo no crec que sapiguem encara com es desenvolupa en els humans, però sí que molts estats alterats de consciència donen creacions noves, increïbles, no? Quan els escriptors, els pintors o fins i tot els inventors han pres bolets al·lucinògens o drogues, no? Han tingut... Aleshores, no sé si a la intel·ligència artificial li hauríem de posar una mica de substància perquè arribi a ser creatiu, no? No sé.
Yeah, like Markov, right? Just don't walk beside a cliff. I think it's a very fair point. If you think about, go back to the 1960s, 1950s, the same people who were experimenting with mushrooms and drugs were the ones who were using computers as something that they called human augmentation. That was Douglas Engelbart. And the augmentation they were thinking about was something they called like bicycles for the brain. Something that doesn't take away all the work, but helps you get things done faster, helps you see things. To me, a computer really is more than a tool. When we say it's a tool, I think we're underestimating what computers can do, because a tool is something that has like a single function, and that is special geared unless it's a Swiss Army knife, but that has a bunch of tools. But a computer is something that is more than a tool. A computer can be turned into something like a medium, something through which you can see things that you otherwise would not see, because it can process large amounts of data very quickly. It can compute a bazillion alternatives before you can think about them, and can filter through massive amounts. And I do believe that this is something that can help us imagine things and help us process things. So about creativity, I would also agree with you, because as you know, your other person said, creativity often comes from remixing things, from being inspired, from thinking about things and saying, what if I put them into a different context? What happens then? My impression is that the current AI systems are rather suffering from this, and I'm a little bit afraid that that we're using them in a wrong way. We're expecting them to be knowledge models, whereas they're just language models. That might change now with reasoning models, but they're not knowledge models. They're also not really creativity models. So I'm always a little bit sad, you know, when companies, big companies, talk about AI, they see dollars in their eyes. They think, I can fire all my customer relationship people because I can now have a chatbot. You're going to call this, and I'm just going to train this on the data, and it's going to talk to you on the phone. What they rarely talk about is that you could use this to maybe get rid of middle management, because that's important, or even top management. An AI could do that. It's not very creative, but instead it makes me a little bit sad that, you know, the authors of movies, or the composers of music, or the artists that draw illustrations are the first ones to fall prey to this new technology. So I would agree with you, but I actually think it's a little bit of a sad development, kind of like when movies with sound killed all the jobs for musicians back in the 1920s. Well, that's a very pessimistic closing note, but thank you.
Moltes gràcies per la teva xerrada. A mi m'has deixat flipat. Però a part d'aquesta preocupació que estàveu parlant ara de que acabem amb els artistes i així, a mi em preocupa també molt la part de pedagogia que estem fent respecte de la despesa energètica que suposa l'ús d'aquestes tecnologies, no? Com l'ús lúdic, no? Bueno, anem a fer un retrat, no? amb aquest estil, o anem a fer un petit vídeo, si realment som capaços d'entendre quina és la despesa energètica que hi ha darrere d'aquestes grans computadores i centres de dades que estan fent servir. Que si tens alguna opinió al respecte.
I agree with you. I think I've said it before. This is something that, from the technology side, clearly indicates that we haven't yet found the right model, because, you know, it uses way too much energy, and our brains work on less energy and are pretty bright too. And I agree with you that this is scary, because it uses up too much of our natural resources and too much of our kind of the things that we need for future, and things that we need to actually improve living conditions in other countries, but also in our countries. And I can only say, yes, I agree. We should be very mindful about this. But on the other hand, also, don't think that this is your individual responsibility. I don't think there is much use to tell people to not stream movies or to think twice before they enter a prompt into ChatGPT. Because that has been the way it has been all the time. There are big companies telling you it's your responsibility to curb your consumerism, when in fact they are making profit on them. I'm going to stop here because I actually think that it goes way deeper. I actually think capitalism is at the problem of it.
Bé, no sé si algú té alguna pregunta.
Hola, gràcies, Jens. Encantat de veure aquesta explicació. De les teves explicacions em sorgeixen dues preguntes. De fet, és una, però amb una introducció. Parlaves que el model no sembla que reprodueixi el que passa dins del nostre cervell, però, de fet, suposo que estarem d'acord en que realment no sabem què passa dintre del nostre cervell perquè té un problema averiguar-ho té un problema principal, que és que en el moment en què intentem mirar-lo passen coses que no són desitjables. I aquí és del que deriva la segona pregunta. Què passarà quan el model, sigui aquest o sigui un altre, aconseguim que funcioni sense que realment puguem explicar del tot com funciona?
I think this is already the case for many things that we cannot fully explain what is happening. Few of us can explain why a transistor works. It's quantum physics, and it's hard to explain. If you look at it, it behaves differently than if you don't look at it. I think the question is how we as humans respond to things that are beyond our grasp and our understanding. Is it something that we feel endangers us as a species, or is it something we can coexist with and maybe even like and even kind of take delight in? Now, here is something that I'm finally able to end with a positive note. I actually am not afraid of artificial intelligence. You know, I came here, I drove all down here from Germany in a car, and it is way more, it has way more strength than I have. I could have walked down here, but it would have taken forever. I don't have that much time. So there are things that are way more powerful than I am, and yet, you know, and I don't even know how it works, this car. But does it threaten me? No. I believe we can take delight in things that are stronger than us, and we can take delight in things that are smarter than us, that might see more than us. We are not the maximum as human beings. We are some local optimum. And there are people I know who are much more intelligent than I am, and I love them, and I don't feel threatened by them. So I feel, you know, this is something that is a chance for us to regain some of the humility that also makes us human.
Alguna pregunta més? Bé, gràcies, Jens, una altra vegada.
Well, thank you so much for coming here. Great.
I recordar-vos a tots que el proper 23 de maig farem la darrera xerrada del cicle d'enguany, que porta per títol Podem fer màgia amb les matemàtiques, a càrrec d'en Sergio Belmonte. Moltes gràcies i bona nit.